welcome to my week 7. This is my second video. This is going to be problem 28.7. So in this problem, we have a hair dryer with a power of 1200 watts and a voltage of 120 volts, and we're trying to find the resistance. So that's just my diagram of the hair dryer. It's not really drawn that well, but basically what we're trying to ultimately solve is this resistance and then the current. So we know that the power is 1200 watts and the voltage is 120 volts. So we can use the equation, at least the first thing I thought of was equating power to the voltage squared over the resistance. And since we're trying to find the resistance and we know both the power and the voltage, we can just plug in those variables that we know, which is going to be the voltage squared, which is 120 volts squared, over the power, which is 1200 watts. So that's going to be equal to 12 volts squared over watts, or 12 ohms. So the second part, we're trying to find the current of the hairdryer, and that's going to be not too bad. We're just going to be using Ohm's law because we just calculated the resistance. So as we know, Ohm's law is going to be equal to voltage equals the current times the resistance, and we are going to be rearranging for the current. So we're going to be equating the current, or that I, to the voltage over the resistance. So now that we have the resistance from the last problem and the voltage of the hairdryer does not change, we are going to have so the current equal the voltage over the resistance, which is going to be the voltage of 120 volts over the resistance, which is going to be 12 ohms, and that's going to leave us with an answer of 12 amps. So nothing particularly tricky about this. This just is another example of using Ohm's law. However, we did have to calculate the resistance knowing the power and the voltage. So once we got that variable, then it shows that we can do a couple other things, solving for other variables in the system. And then yeah, so that was the only really part in terms of tricky parts. Like I said, just knowing to use that power equation, and then ultimately once we find a resistance value, then we can find the current using Ohm's law. So yeah, that is my second problem. So thank you.